In the last video we looked at the definition of the cross product of two vectors A and B. In this video we will consider vectors in 3 dimensions. So we can represent vector A in terms of the I, j and k basis vectors. Similarly for vector B, we can represent it in terms of I, j and k unit vectors. Now it turns out that the cross product is distributive over the addition of vectors. I won't prove that in this video. So we can take the first term in here, which is a1i, and get the cross product of it with each of the terms of vector B. So that's what we have here. Then we can take the next term of vector A, a2j, and get the cross product of it with vector B, and finally the a3k term, get the cross product with that, and we can break that down further. We can take a1i and cross it into each of these terms. The cross product of a1i with b1i is a1b1 times the cross product of I with itself. So the scalars a1 and b1 can be taken out to the front, and we just have the cross product of I with I. Similarly, for the next term, we have a1b2 times the cross product of I with j. Then we have a1b3 times the cross product of I with k. And so on. We can do the same for a2j and for a3k. Now we saw in the last video that I cross I is 0 because I is parallel to itself. If two vectors are parallel, then their cross product is 0 because the angle between them is 0. The sine of 0 is 0. So this term is 0. Similarly, j cross j is 0, so this term goes out, and k cross k is 0, so this term here goes out. Now here are the results of the last video for the other cross products of the unit vectors. So we can apply them in our situation. So this is what we saw in the last video. Actually, these 3 rules are quite easy to remember. I comes before j in the alphabet, and j comes before k. So if you want to get I cross j just gives you k. That's the first rule here. J cross k gives you I. So we're moving from left to right and cycling back. And finally, k cross I gives you j. Then I cross j gives you k, j cross k gives you I, and so on. So this is 0. This one here is k. I cross k doesn't appear yet. I'll get back to that. What about j cross k? That's here. So that's just j cross k is just I. K cross I appears here. That's just j. Now what about the others? Well, this is 0. Well, we just use the fact that these do not commute. J cross I is actually given by minus k. K cross j is given by minus I, and I cross k is given by minus j. So if we turn these around, we just change the signs here on the right hand sides. So that's what we have here. We have I plus cross k here, which is minus j. Over here we have j cross I, which is minus k. Then here we have k cross j, which is minus I. Now let's gather up the terms involving I. Well, these 2 terms involve I. So the coefficient is a2b3, and because of the minus sign we have minus a3b2. Now let's look at terms involving j. Well, we've a3b1 times j, and from this term we've minus a1b3. So we could write it like this. If we take out a minus sign, then this would become plus a1b3. Take the minus sign out, but if we take the minus sign out here, we have to have minus a3b1 to give back the plus a3b1. And finally, the k terms. Well, this is plus a1b2, and this one here has a minus sign, so we have minus a2b1. Okay, so we could apply this formula for getting A cross B. Now later on we will see an easier way to get A cross B using the determinant of a matrix. It's easier to remember than this thing. So let's take an example. Here's vector A and here's vector B. So you can see A1 is 3, A2 is minus 2, A3 is plus 5, B1 is plus 7, B2 is plus 4, B3 is minus 8. We just plug all those numbers into this thing here. So anyway, this is what we get now. In future we will use the determinant method to do this. Here's an example that has no k components. So A3 is 0 for vector P, B3 is 0 for vector Q. So that simplifies things a little bit. Anyway, I won't go through that one. That's just plugging in. Now, let's see how to use determinants. This is the way that we will usually do it. Here is the formula that we will use for A cross B. We're getting the determinant of this 3 by 3 matrix. The first row of the matrix consists of the unit vectors I, j and k. The second row consists of the components of vector A. And the third row consists of the components of the second vector, which is B. Now up here we have a reminder of how to calculate the determinant of a 3 by 3 matrix. We can use any row or column to get the determinant. Now the way that this particular one is done is by using the first row, A, B and C. So that's why you have A here, B here and C here, but you don't have to use the first row. You could use any row or column. It's preferable to use a row or column that has a lot of zeros in it, because if you have zeros appearing for A, B and C, then obviously we get rid of a lot of work here. But anyway, I'll just run through this again as a reminder of how to get the determinant using A, B and C. We take A, the first element in the first row, and cross out the row that A is on and the column that A is on, and we get the determinant of the remaining 2 by 2 matrix. So we get the determinant of EFHI. Next we move on to B. Now we stick a minus sign in front of B, and we cross off the row that B is on and the column that B is on, and get the determinant of the remaining 2 by 2 matrix. That's the matrix DFGI. Finally we go to C, cross the row and column that C is on, and get the determinant of the 2 by 2 matrix DEGH. Now I just want to get back to the signing. Now the entry in the top left corner is assigned a positive value, so it doesn't change sign. So whatever it is, it remains as A. Every second one has a negative sign assigned to it. So if A has a positive sign, then B must have a negative sign assigned to it. So we stick a minus sign in there. C will have a positive sign, then D will be negative, E positive, F negative. We're not using D, E, F, G, H or I to calculate this determinant, but if we were, we would follow the checkerboard pattern: plus, minus, plus, minus, plus, minus, plus, minus, plus, etc. So now, to get back to this formula, let's just run through getting this determinant. Of course, we know that the answer has to be this that we got earlier. Well, let's suppose we use the first row to calculate the determinant. So we write down this entry, which is just I. As I said, we assign a positive sign to it, so it doesn't change sign. And we multiply it by the determinant of the remaining 2 by 2 matrix. So that's the determinant of A2, A3, B2, B3. Then we go to the next entry, J, and we assign a minus sign to it, as I explained earlier, following the checkerboard pattern: plus, minus, plus, and so on. So we imagine crossing out the row and column that J belongs to and write down the remaining entries. So that's A1, A3, B1, B3. Finally we get to K, cross off the row and column that K is on, and we get the determinant of this matrix. Assign a plus sign to K, so we have A1, A2, then B1, B2. Now if you haven't seen these before, to calculate the determinant of a 2 by 2 matrix, we multiply these entries together. We multiply down this diagonal, that's A2, B3, gives us that, and then we have a minus sign, and then we multiply A3 by B2 to give us that. Here we have minus j, and we multiply A1 by B3, and then we have a minus sign, and after that we multiply A3 by B1. Similarly here, plus k times A1 B2 minus A2 B1. So if you're well versed in calculating determinants of 3 by 3 matrices, it's by far the easiest way to get the cross product. You don't want to be memorizing this thing here. So that formula checks out. Now let's do an example. So we want to get the cross product of this vector with this vector here. So our first row is ijk. The second row is the components of vector A, that's 3 minus 4, 2. The third row involves the components of vector B, 9 minus 6, 2. So we will use the first row to calculate the cross product. So we cross out the row and column that vector I is on, and we have the determinant of minus 4, 2, minus 6, 2. So we multiply minus 4 by 2 and subtract 2 times minus 6. So we get minus 8 minus minus 12. Next we go to j, we give it a minus sign. We cross off the row and column that j is on, and we have 3 times 2 minus 2 times 9. That's 6 minus 18. Finally we go to k, that's plus k, cross off the row and column that it's on. We have 3 times minus 6 minus minus 4 times 9. That's minus 18 minus minus 36. We simplify that to get our answer.